So I think if we go through these questions together and you write down sort of anything that you haven't already answered, I think this will serve to help you on the homework for 8-7 for the weekend. So first off, the diagonals are equal in length for which 3 quadrilaterals? Square, rectangle, and there is one more, isosceles, trapezoid. Okay? All right. Now, if we know that the diagonals are equal in length, let's think about another property that we know about diagonals. Every parallelogram has diagonals that bisect each other. This means that the point where the diagonals intersect each other is called the what? Okay, now keep going down that, like, what do we call the actual point where a bisector? Midpoint. Okay. Now, this probably means you might need to use the midpoint formula. Do you remember what that is? No. Let's review that. The midpoint is an ordered pair. Okay, and it's the average of the x's, so x1 plus x2 divided by 2, and it's the average of the y's, y1 plus y2 divided by 2. Now that is something that you're going to need to use on 8.7. So let me give you an example of a couple situations. So let's say we're talking about a square. All right, so in a square, we know that the diagonals are going to bisect each other. So if you were to calculate, let's call this one, I'm going to make it in red. Let's call this one diagonal 1. If you're going to calculate the midpoint of that, it's going to land right here. If you then go and calculate the midpoint of this pink diagonal, it better land in the exact same spot, right? Because we know that the diagonals should bisect each other, so their midpoints should line up. But let's think about a shape where that doesn't happen. So what's a shape that's not listed up here? What's a shape where the diagonals are not equal? Okay, trapezoid would work.
A circle?
Let's do a trapezoid, a circle. Doesn't quite fall under quadrilaterals. All right, so I'm going to draw in these diagonals, and I want you to recognize that their midpoints are not at all going to be in the same spot. So this might be a helpful thing. Like this would be the midpoint of that pink diagonal, and if I eyeballed it on the orange one, that would be the midpoint. So if you're comparing midpoints, if you see that the midpoints are completely different locations, that automatically will help you know, oh, it could be a kite, it could be a trapezoid, it could, it's definitely not a parallelogram, because parallelograms will always have the same midpoint for the diagonals. All right, true or false? The slopes of the sides of a square are all equal.
True. No.
False. That's not how slopes work.
Whoa, I tricked y'all with that.
All right, how about I draw a regular old square with horizontal and vertical lines? Wouldn't the slope of a horizontal line be constant, 0?
So I was right.
What's the slope of a vertical line?
Undefined.
Undefined. Are those all the same?
Yes.
Is 0 the same as undefined?
Yeah.
No. So this is false. Okay, so slopes are not all going to be the same, but there will be a slope relationship. They will be perpendicular. Like maybe, what if you calculate that this is 3/5? Then and then you calculate this slope. If it's -5/3, then you would know that they are perpendicular. Okay, but they're not going to be equal. True or false? All squares are also rectangles.
No. All rectangles are squares, but not all squares are
No.
Careful.
Think of
rectangles.
Not all rectangles are squares.
The square is the baby of a rectangle.
That's like
So all squares are rectangles? True. Okay. But it does not work the other way around. Number 5, true or false? All rhombuses are also squares.
True.
False.
Undefined.
All rhombuses are also squares. Well, wasn't it like rectangle, and rhombus have a baby, and that baby is a square? Okay, so are all of these rhombuses going to be squares? No, only special rhombuses are squares. So this is also false. A square with sides of 5 has a diagonal of what length? Oh, we really are having a case of the Fridays, aren't we? Let's find our diagonal.
5 root 3.
Close. 5 root 2. Okay, how do we know that? What kind of triangle is this?
Wait, when did
This is a 45, 45, 90. Any triangle in a square is a 45, 45, 90.
Oh my god.
All right. 45, 45, 90.
Stuff.
All right, you guys, these are the easy questions. Okay, if given the ordered pairs of the vertices of a quadrilateral, A, B, C, and D, which segment slopes would need to be equal in order for it to be a parallelogram? This is what your homework is like. Okay, this is what 8-7 is like. What I would suggest that you do is if you don't have a picture, draw yourself a generic picture and label it A, B, C, D. Now, if we want it to be a parallelogram, okay, so in order for it to be a parallelogram, this would have to be parallel to this. So then what would have to be true about this slope and this slope? They would have to be the same. So the slope of AB must be equal to the slope of CD. Now, parallelogram will have both pairs of sides parallel, so this pair will be parallel, which would mean that the slopes of AD must be equal to the slope of BC. This is the kind of thing you're going to have to look for in your homework. You're going to be asked to calculate slopes and then start to figure out what shape is it. All right, so something like this. Did anyone figure out what shape this was?
I hadn't even got
A trapezoid.
Is it?
I think it's a rhombus.
Let's see.
Oh, wait.
Why don't we draw a picture to put the information in the context of the picture? So I'm going to make a generic shape. A, B, C, D. All right. The slope of AB is -2. So I'm going to put here M is -2. The slope of BC is 1/2. So M is 1/2. The slope of CD is -2. M is -2. The slope of DA is 1/2. Okay. Do we have parallel lines?
Yes. No. Yes.
Because these are the questions you're going to have to ask yourself to figure this one out. Which lines are parallel? Top and the bottom. This one's parallel to this one. Are the other two parallel to each other? Does a 1/2 equal a 1/2?
Yes.
Okay, so that is parallel to that. All right, now, so far we can really just call this a parallelogram. The question is, can we call it a more special type of parallelogram? Then you have to look at this and go, does this slope and this slope have a special relationship to each other?
Yeah.
They're perpendicular.
Do they happen to be opposite reciprocals?
Yeah.
Yes, they do. So therefore, these are perpendicular.
Oh.
You have to look for these things because now I know that this is perpendicular. I know that this is perpendicular, and this is perpendicular. So now what could it be? It could be, because of this, it could be a square or it could be a rectangle. Okay, great. We've narrowed it down to 2 possible shapes. There's more information that's going to help us narrow it down further. All right. So what other information we have? We have AB equals CD. So this leg equals this leg. BC equals DA. So this leg equals this leg. So the opposite sides are congruent. Does that help me narrow it down?
Yes.
Opposite sides being congruent is just a parallelogram property. Okay, but what about this right here? AB is not the same length as BC.
No, square. Rectangle.
So therefore I can rule out the square. It is definitely a rectangle. All of this information is something that you're going to end up having. This is like a proof. We just didn't do it in a 2-column way. It's like an algebraic proof. Okay, so let's try the next one. So this one, given the following facts about this shape, what shape could it be? All right, do yourself a favor. Draw a picture. You saw how helpful that was. Just a generic picture and label it A, B, C, and D. All right, slope of AC is -2. Oh, that's a diagonal. Without the picture, would you know that? Or would you just assume that that was a side length? You'd probably accidentally assume that. So the picture is really helpful. All right, so this has a slope of -2. Now, the slope of BD is 1/2. So this slope right here is 1/2. Okay, well, they're definitely not parallel. Diagonals shouldn't be parallel. But do these slopes have any sort of special relationship?
It's an opposite reciprocal.
They are, in fact, opposite reciprocals. So I know that these are now perpendicular. Oh, well then what shapes are the shapes that have perpendicular diagonals?
Rhombus or triangle.
Rhombus, square, and a kite. So I have now narrowed it down to 3 possible shapes just because of that bit of information. So now let's see what the other information is giving us. AB equals DA. So this equals this. BC equals CD. This equals that. And then this is saying AB does not equal BC. So these sides right here are not congruent. So I can rule out the square and I can rule out the rhombus.
It's a kite.
So now I know it's a kite. All right, last one. Okay, generic shape A, B, C, D. A, B, C, D. All right, what do we know about it? We know that the slope of AB is -2, so M is -2. The slope of CD is -2, so M is -2. Is that a special slope relationship? Yeah. So I know that these are parallel. Okay. I am not told about the other sides. I am not told that these have a parallel relationship. So I'm kind of thinking we're leaning down towards, what's the only shape that has like one pair of parallel sides?
Trapezoid.
I'm kind of thinking these might be trapezoid. This might be a trapezoid. Let's see what else is given. The distance from, I think this is meant to say B to C. So like this is equal to the distance from D to A. So that. So we definitely only have one pair of parallel sides, and then these other sides are equal in length.
That's a trapezoid.
And is it a special kind of trapezoid?
Isosceles.
Yeah. This one is an isosceles trapezoid. All right, so this is what you were doing on 8-7. You have a long weekend to do it. Have fun.